Hello and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT Science series. You already know on StudyIQ, we are running a series where we are discussing NCERT texts of science and we have already reached class 8. The agenda here is to discuss chapter by chapter. Until now, we are already done with chapter 1 to chapter 10. Now, in these chapters, we discussed some topics about agriculture, some topics about materials like metals and non-metals, coal and petroleum. We also understood some processes like what is combustion, what are the characteristics of flames. Apart from that, we also spoke about certain topics from biology. We spoke about microorganisms. We discussed about cell, its structure and functions. We talked about reproduction in animals. And in the latest discussion, we discussed the adolescence. That means changes that occur during the adolescent age. And now we'll be moving towards chapter 11. Now you must be thinking, sir, why did you give a recap of these 10 chapters? Because there is a change in theme. Now before this, we were talking about materials. We were talking about topics from biology. But now the focus shifts towards physics. So what will we understand in chapter 11? The name is very innocuous, right? Force and pressure. Sounds very easy. Of course, it is easy also because we'll be talking about what is force, what is pressure. We'll be discussing what are the different kinds of forces mentioned in NCERT. What is pressure? Is pressure exerted by gases? Is pressure exerted by liquids? All these things would be understood. But again, although the chapter looks very innocent, but you need to focus on certain aspects. Whenever I'm discussing this, I'll be giving certain examples from our day-to-day activities, which is very important for us. See, aspirants come and ask, sir, how do I prepare science and technology? I always give one advice. I tell them, prepare science and technology topics on the go. Prepare wherever you are. Just observe things around you. There is science and technology in each and every aspect. So try to connect whatever you have read here or whatever discussed here with your day-to-day examples, because questions appear from that only. For example, every day we employ force for doing some work, right? Say I am holding a pen. I am applying certain force on this pen to hold. 3 fingers are holding this pen. That means some force is applied. A simple example. You must have seen yoga in the morning, right? Yoga gurus, they tell you to apply some pressure on your fingertips like this. It will regulate your nervous system. They tell you press or apply pressure on the pressure points on your palm, the mounts of your palm. Why? Because it has some regulatory function with your nervous system. But the question is, why did they say pressure here? Why not force? Apply some force here. Why pressure? So what is the difference between these two? What are the nuances? Of course, both the topics are connected, but we'll discuss it through many examples. So let's begin our discussion without any further delay. But before all this, there is a small notice for all of you. If you're preparing for UPSC Civil Service examination, then the window is closing out for batch 7 as well. You've already missed out the batch 6. It started on 20th May, but you can join 25th May batch 7 evening batch. The classes start at 6 p.m. You'll be asking, sir, why should I join? Because this is the most comprehensive program for UPSC Civil Services preparation. We will be hand-holding you from day 1 till your interview phase. If you clear your prelims, UPSC Civil Services 2024, the entire expenses of your mains residential program, its preparation would be taken care of by StudyIQ. You'll be called to Delhi Center where you'll be preparing with the educators directly. All the expenses of that by StudyIQ. There will be mock interviews. There is already one-to-one mentorship, group mentorship, current affairs program. There is already mains answer writing program. There is also prelims test series, everything included. And the cost of this is very affordable, 29,999. If you want discounts, heaviest discounts, use my code Rahul Live on the app or on the website. It works anywhere. Whenever you check out, just use Rahul Live, then press apply. I'll see you in the class. Right, let's talk about force and pressure. Now, as I told you, in our day-to-day life, we use the concept of force. For performing any action, we need force. For example, I told you I'm holding a pen. So I'm applying force using these 3 fingers at these spots to hold a pen in a steady position. Every day. So you play football, you kick a football, you're applying force. You're playing cricket, you're bowling, you're applying force. You're hitting a 6, you're applying force. So everywhere, force is being employed. You can see certain examples. There is football, there's cricket, there's hockey. Day-to-day activities, you see force. But what is the definition of this force? What are the characteristics of force? Now, in science, a force can be a push or a pull. Now remember, this push or pull, it will impart some motion. For example, if there is a pen here, if I'm pushing this pen is moving from one spot to another spot. If I'm pulling something, then the object is moving from some far away position to a nearer position. So force can be a push or a pull. Now the question arises, what are the characteristics of it? Sir, say for example, there is a wall. Now I am applying force on this wall. Is there any interaction or is there anything happening here? That is what we need to understand, because forces are always due to interaction. All right. See, I am standing here and there is a car there. I'm not doing anything. The car, how will it move? I have to start the ignition, or if there is a driver inside, they will start the ignition and then the car will run. Imagine the car is not starting. So what will you do? If you're simply standing, the car is not going to move. What will you do? To move the car, you will push the car. That means there is an interaction between you and the car will start moving. That is force. There is always an interaction. You can see there are so many examples here, right? A person is standing here. There is no force acting right now because he's not pushing the car. But as soon as he starts pushing the car, that means he's applying the force. There is some sort of interaction. You can see example that one girl is pushing another girl and the other girl is retorting back. She's also pushing back. There is also one example of pulling. There is an example of a farmer and a bull where both are pulling each other via a rope. There is some sort of an interaction that is happening. And that is why force, or what we call as net force, is ultimately leading to some sort of motion or some sort of change in the object. That's why force, whenever it is applied in a direction, the two forces in same direction, they add up. Whereas the two forces which are acting in opposing directions, they cancel out each other, or whichever is the highest, it will act more. So forces, they need direction. Now, if we look at this particular example, you will see that the person here is pushing the car. That means force is acting in this particular direction, whatever force is employing, F. That means force, there is some sort of a magnitude that the person is pushing in one particular direction. Now here, a girl is pushing another girl and the other girl is retaliating by pushing her. That means there are two opposing forces. Now this girl is pushing this side, this girl is pushing from this side. Now what is going to happen? There are two opposing forces which are acting, and whichever is higher, that is going to push the other person. Now the same thing here, there is same pulling force. This lady is pulling the other woman here, and this woman is pulling on the opposite side. Whichever force is higher, the net force would be the difference of these two, and whichever is higher, the movement would be in that side. The same case applies here with the farmer and the bull. Now, why did I tell all these things? Why did I tell you all these things? I told you that force has to have certain magnitude, meaning I apply some X amount of force on one particular object. That is called as magnitude. And we all know from the Newton's second law, which we'll be discussing in our subsequent classes, but I'll just tell you the formula right now. Force is equal to mass into the acceleration, right? It comes from the second law given by Newton. The rate of change of momentum is directly proportional to the force acting, and it takes place in the direction of the force, in the direction of the force in which it is acting, right? So magnitude is very important, but apart from magnitude, the direction of the force is also very important. You can see the example here also, that two people together are trying to push this box. That means if one person is employing force X and another person is employing force Y, both are in the same direction, the net force that is applied here would be X plus Y. But if two people are pushing it from the opposite side, one person is pushing from this side, another from this side, then if this is X, this is Y, then we will check the net force to be difference of these two. They cancel out each other. Why did I tell you this? Because we need to understand certain features called as scalar quantities and vector quantities. In physics, we define certain quantities only based on magnitude, only based on the amount, the magnitude of that particular entity. Scalar quantities are one which are defined only through magnitude. Only magnitude is enough. For example, distance. I say I traveled from one place to another place. and the distance was 10 kilometers. It is enough. But as soon as I bring in the concept of direction, that distance turns into displacement and it becomes a vector. A vector is a quantity which has both magnitude and direction. You can see some examples here. Scalar quantities are length, area, volume, speed, mass, density. But vector quantity is one which is with a magnitude and which is also with a direction. Please remember, force is a vector. Pressure that we are discussing is a scalar quantity. Very interesting, isn't it? So we'll be developing more on this in our subsequent discussions as well. But right now you need to understand force is defined as a push or a pull. It has characteristics. It has a magnitude, the amount of force that is applied. It has a direction, in which direction it is being applied. Then there are some scalar quantities like pressure, where only magnitude is enough to define. Right? Let's move on. Now apply force on something. I apply force on something. Then what happens? See, force, it is going to bring a change in state of motion. Now what is the state of motion? You can see the example here. We used to do this when we were children, right? Take a tire and roll that tire. The kid is applying a force on this tire and this tire is moving. That means a motion is imparted to the tire. Similarly, if I apply a force, imagine the same tire is coming towards me with some sort of a speed. I simply stop it. That means I give a push to it, the tire is stopped. That means a moving tire has been brought to rest. That means force is leading to some sort of change in the state of motion. It may be moving or it is brought to rest. Please remember, state of motion, it can be a moving thing or it can be at rest. State of motion is both. Being at rest or being in motion, both are considered as states of motion. Rest means where the speed or the velocity is zero. It's not moving. For example, there is a chair here. The chair is in a state of rest. Right now I am here. I am in state of some motion because I'm moving. I'm trying to explain you certain things. That means some amount of force is being employed to speak. Some amount of force is needed. That means because of that force, the vocal cords are moving. The diaphragm is moving and sound is being produced. Right? So force can change state of motion. It can impart motion. It can put things into motion, or it can also bring to rest things which are in motion. Now, apart from that, force can also change the shape of the object. Now, it depends on the object. I told you an example that there is a wall. Now, I apply force on it. Nothing is going to happen. But imagine this particular wall being made up of a very soft metal, say sponge or say a dough. You can apply force on the dough, right? Then the shape of the dough changes. You must have seen, if I apply constantly force on the chair, the shape of the chair changes. If I pull the rubber, I change the shape of the rubber. So what does force do? See, force can first of all make an object move. If it is at rest, make it move. If it is moving, bring it to rest also. It may change the speed of the object. It may increase the speed. It may decrease the speed. It may also change the direction of motion. Say, for example, the tire was moving. I am just hitting the tire and the tire is moving in this direction. I hit it from the other side. It will change the direction, right? It may also bring about change in the shape. Or remember, it can also bring all these things together. All these things together also. There is a possibility of that as well, right? So anything can be happening. Something can be put into motion. If something is in motion, I can bring it to rest. I can reduce its speed. I can increase its speed. I can change its direction from one direction to another direction. I can also change the shape by using or employing force, right? Those are the characteristics of force. Now the question is, what are the type of forces that we use in our day-to-day life? See, forces are generally classified here in two ways. One is contact force and another would be, obviously, it would be non-contact. Now, contact force means where I need some interaction between the two. As I told you, I want to move this pen. I want to move this pen from this position to this position. That means I have to make a contact with this pen, take this pen from here to here. This is a contact force which is being applied. So, contact forces can be muscular force. Now, this is muscular force. my muscles are working, and because of my muscles, I'm holding the pen, I'm moving it from here to here. This is the example of muscular force. Muscular force is a contact force. Why? You need contact. Muscular force was used before, even now we use it. There is an example here. We use the draught power or draught force of the animals for agriculture, for transportation, many things like these. This is muscular force. But apart from muscular force, in our day-to-day life, we have something called as force of friction. A very interesting idea. Force of friction, always because of contact, between two things. You must have observed that you are riding a vehicle. Now you accelerate the vehicle and switch off the ignition. The bike will move from one point to another point, but after some point, without acceleration, without the engine being on, the bike will halt. The same applies to car. For example, in cricket, a player hits a shot. The ball starts moving. As soon as the contact is made, some amount of force is employed on the ball, then the ball is rolling around the ground and it does not reach the boundary. Why? Because there is some sort of a contact force which is acting on the ball, which is acting on the tires, when I gave you the example of a vehicle. And that force is called force of friction. Now this is acting between two bodies which are in contact. For example, I'm standing right now. Why am I stable? I'm standing, I'm walking, because there is some amount of friction force which is acting between my feet and the surface, because of which I am able to grip the surface and walk very easily. If there was no friction, I would be falling, I'd be slipping off. In fact, we'll talk about friction more and more in a subsequent chapter itself. But please remember, force of friction, first of all, it is a contact force. It is a force which is responsible for both motion as well as bringing something to rest. And remember, the force of friction, it always acts on moving objects in its direction. If I say in its direction, which is opposite, meaning, say, if there are two surfaces and the friction is happening in this direction, that means motion is in this direction, friction would be always in the opposite direction. Please remember, force of friction always on moving objects relative to one another, and its direction is always opposite to the direction of the motion. If motion is in this direction, that means this is the moving force F, then the frictional force F would be in this direction, opposing direction. Clear? Now you will get more information on this because this is very important for us. Many questions do come from friction topic, and in our next chapter, do not miss it, we'll talk about friction more and more, types of friction, and all the details about friction will be discussed. So first thing, contact force, a muscular force, force of friction. But there are many non-contact forces that we see. We have discussed about magnetism before. In our previous chapters, previous NCERT class 6 and class 7, we discussed about magnetic materials. I told you one of the first discoveries was that of lodestones, right? This is a magnetic material. Now, magnetic materials also push or pull things, right? You know, if I hold a magnet, if I hold a bar magnet, say this is a bar magnet, this is a north pole. Now, what is going to happen? If this is south pole, it is going to pull it. And if both of these are north pole, then these are going to repel each other. That means there is some sort of a force which is acting on another body, but remember, this is without any contact. There is no need of contact here. These are called non-contact forces. Magnetic force is a non-contact force. It can be attraction or repulsion. That means, again, you can define it as a push or a pull, but without any sort of contact. There is no need that the another metal should be magnet. You know, both need not be magnet. You do understand, a magnet and a magnetic material are more than enough for this push and pull. It can be between two magnets or between a magnet and a magnetic material. Magnetic force, an example of non-contact force. Now, apart from magnetic force, we also have electrostatic force. So this also we have seen when we spoke about electrostatic force and electric current. I told you during our childhood, we have conducted this experiment. At least I have conducted this experiment, right? Take a comb, rub that comb on a piece of wool, and it is going to attract small pieces of paper. Why? Because there are some charges on this particular comb which are now being neutralized by attracting. We have seen this, right? So electrostatic force is also a non-contact force. Remember, contact may be there, contact is not mandatory. It may be again a force of push or a force of pull, both. It is possible. It can be attraction, repulsion, based on the charges. You already know, like charges repel each other, unlike charges attract each other. So we have seen this in our day-to-day lives. We have conducted this experiment. We also know about why charges are formed in clouds, right? In fact, we'll discuss this in our subsequent discussion also. In the future discussions, we'll understand how charge is created in these clouds. We'll get more clarity over that. This is an example of electrostatic force. Apart from magnetic force, electrostatic force, there is one more non-contact force which is very prominent, which we feel also right now. See, I am standing on the ground. Why? Because there is some sort of gravitational force acting on me, because of which I am grounded on earth. That is the gravitational force. And remember, a magnetic force, it can be attraction or repulsion. It means push or a pull. Electrostatic force, it can be attraction or repulsion based on the charges. It can be push or a pull. But gravitational force is always a pull towards the body, right? Again, Newton's law of gravitation, it suggests that between two bodies, the force of gravitational, it is dependent on the gravitation constant, right? Apart from that, it depends on the masses of the body and the distance between them. So gravitation force is always a force of attraction. Now, because of this force of gravity, I'm grounded. We already know G is equal to 9.8 meter per second square, right? Now, what is this? This is the property because of which everything is pulled towards Earth. Now, we all think that it's only a phenomena which is peculiar to Earth. No, it is seen in almost all celestial bodies. In fact, every body attracts another body. But if the masses are very, very small, the force of gravitation would be very, very low, because G itself, it is very small. So the gravitation constant is very small. The gravitational force would become very relevant for celestial bodies. That means the gravitation force of Sun is bigger than the gravitational force of Earth, right? It depends on the masses as well. So please remember, this force of gravity, it is not peculiar to Earth alone. It is a property of entire universe. Whether a small object or a large object, it always exerts another attractive force on another body. But because of very low masses, say for example, for humans, there is gravitational force between humans also, but it will be very, very small. In fact, this is one of the weakest force in the physics model itself. Now, apart from these forces, there is one more thing that you should know, which is out of this NCERT, the nuclear forces. We'll talk about this when we talk about the model of atom, etc. We already know, when we talk about the model of atom, there is nucleus, and in the nucleus you have protons and neutrons, and there is an electron cloud which moves around this nucleus. There are different models which have been given, like Niels Bohr has given, Rutherford has given, Thomson has given. So all the models, they basically point out there is a central nucleus which has positive charge because it has protons. To balance it, there are neutrons. Nucleus, which is positively charged. Around it, negatively charged electrons are hovering or revolving in electron shells or in a cloud basically. Now there are nuclear forces which are acting in an atom. Now in the nucleus, there are strong nuclear forces, because it is very strange that there are protons present in a nucleus. That means somehow they are interacting, because of which the nucleus is very strong at the center. And there is also weak force. There is weak force, that is the electron force or a neutrino force, which is a weak nuclear force, because of which the atom is stable, or else the electron would have collapsed into nucleus, isn't it? Now this model, does it make sense to you? Because now this is positive charged, and I'm telling you electrons are revolving in a cloud. Now if there was no force interaction here, this electron would have collapsed into nucleus, but it doesn't happen because of the weak forces, right? So this basically completes the fundamental forces that we have. We spoke about the electromagnetic force or electrostatic force. Now again, we'll talk about this in future also. But there is strong nuclear force, there is weak nuclear force, and there is gravity force. And gravitational force is one of the weakest force, because its strength is very, very low. And the strongest force, of course, the common sense tells me, strongest force is the force of nucleus, a strong nuclear force. Clear? Right. So this was about force, different kinds of force that are mentioned. Now another topic connected to pressure. Now when I apply force, now I told you force is a push or a pull. Now when I calculate this push or a pull on one particular unit area, it becomes pressure. So pressure is basically force that is applied on any specific area. And if this area is unit, that means it is 1, then pressure, it becomes force. So pressure is nothing but force that is applied on unit area. That is how we calculate pressure. Now why this concept of pressure is very important? So let's look at this picture and let's try to understand. Now what is this guy doing? He's carrying a lot of luggage. Now you must have seen porters, right? Porters, or in colloquial language or in Hindi we call coolie, right? There are movies also, Coolie number 1, Govinda starred in it. So this guy is carrying a lot of luggage. Now you will see he's carrying 2 bags on his shoulder here. He's also carrying a suitcase and a bag on his head. Now you will see there is a lot of pressure right now on his head. Can he carry few more bags? The answer would be more, because the pressure is going to increase more and more. Why? Because the force is acting on a very small area here on the head. So there is I would say limited capacity that he can carry on his head. So my question is, can he carry few more bags probably on his shoulder? Now you might say yes. Yes. Why? Because the contact area on which the force is acting here, you can see from here to here the force is acting. Now same example, you must have seen many people carrying a quintal bag, that means 100 kg bags on their back. Now how can they do it? Can a same person carry 100 kg bag on his head? The answer would be no. Why? It all boils down to the concept of pressure. Because if the force is distributed on more area, I'll be able to bear more pressure. Means if I take a bag on my back, probably I'll be able to carry more. Why? Because the force is now acting on more area. Right? See, this is the basic application that we use. Now, as I told you, pressure is basically equal to force by area. That means the pressure will be more and more if the force is more and if the area is less. That's what I told you. All right. If area is increased, if more and more area is increased, then the pressure would be low. That's why I told you, if I carry a bag on my back, probably I can bear more pressure. The same cannot be said for the head. And these examples are very much valid in our day-to-day life. Now you must have seen, you must have taken a knife. Take a knife which is sharp and take a knife which is blunt. Why is it tough to cut it with a blunt knife? Because the blunt knife has more area. That means less amount of pressure can be employed. You can see here. That's why if a knife is very, very sharp, that means the area of contact is very low and the force that you use, it is going to impart more pressure. That is the same concept that you use with knife, your scissors and your cutters basically. Why? Because the contact area is very less on which you are applying a force. That means more and more pressure is employed. The reverse applies in many other places. For example, if I want less amount of pressure, I increase the area of contact of area of application of force. Now you must have seen that if I'm carrying something like this, directly on a rough ground, now what is going to happen? I have to push it more and more. But if I use wooden logs like this, I'll be able to move this very, very easily. Isn't it? Why? Because I have increased the area of application of force. So pressure is less, I can easily move it. The same applies here for a footballer or for a cricketer. They use shoes with spikes. You must have seen with spikes. Now, why do they use these spikes? What is the use of this spike? See, my weight is constant. That means the amount of force, I told you, pressure is equal to force by area. Now, the force that I can apply using my weight would be say 72 kg only. Right? 72 kg into, if you do G, you will get into, if you do 9.8, you will get it in newtons. Okay. So what is the maximum amount of force that I can put on the ground? 72 kg. Now with this 72 kg, can I push the ground, or can I get a better grip? I may not. That is why I use spikes. And using these spikes, what happens is I am reducing the contact area, but I am putting same amount of force. Now what happens? These spikes will grip the ground in a better way. Now this person is digging. Now what is he doing? He has a shovel. Now the shovel is pointed, and when the shovel is pointed, with less amount of force, I can pierce, I can dig very easily. That's the concept, right? Now same applies in a reverse way. You must have seen so many animals. You must have seen the elephant. Now elephant has larger feet. Why? Because it does not want to put too much pressure on the ground. It wants to be safe. Even if the ground is not hard, even if it is shaky, it wants to stay stable. Or example, I gave you this example. Now if this person, if he wants to carry 2 more bags, he may. Why? Because the band is making good contact. You must have seen with children that they carry a bag, and the band of the bag is normally wider because the area of contact is increased here, because of which there is lesser pressure on the back. So day-to-day activities, you will see the concept of pressure. And it is not just for solid surfaces. Please remember, till now we spoke about examples, right? Solid, say cutting, right? Cutting, walking, taking stuff, moving stuff, all these things. But pressure is also exerted by even liquids and gases. You must have seen, just take a bottle, just take a water bottle, and you will see that it is exerting pressure in all sides, right? We know about the hydrostatic pressure. Water exerts pressure, liquids exert pressure. Now if you make a hole in this bottle, you will see the water is going to spill out of this. And this pressure, it is basically proportional to the height. Now in this bottle, the more the water, the higher the pressure it puts on the bottle. Same applies with gas as well. There is a balloon. Now this balloon is filled with air. Air means gas. Say imagine, say it is filled with helium. Helium means helium is now exerting pressure on the balloon. Same thing applies to your tube. You have a vehicle. In that vehicle is a tire. Inside the tire there is a tube. In that tube there is air itself. There is gas in it, and that gas is exerting pressure on your tire. That is why your tire is not being flat. It's not getting flat, and it is easy to move. The same applies in these boats, right? The inflatable boats, etc. So pressure is exerted by both liquids and gases. Of course, I gave you so many examples in our day-to-day life also with solids. Say I gave you example of yoga. Now what do? I told you the yoga guru tells you to apply pressure on your fingertips, apply pressure on the mounts of your palm. Now what are you doing? You are applying pressure. That means I am taking a pointy finger and I am applying pressure here, right? That is the meaning. Means I am pinpointing it, reducing the area of applying the force. All right. Now apart from this, we also have atmospheric pressure. Now we know that. Now atmosphere just over me, it is exerting pressure on me. Why is it exerting pressure on me? Because of gravity. We already have established that air has mass, correct? Air has mass. Air is made up of different particles. Air has nitrogen, air has oxygen, air has carbon dioxide, air has different things. Air has dust particles, particulate matters, all these things. Now all these things are continuously pushing from above. Why? Because of the action of gravity. Because of the Earth's gravitational pull, what is happening is air is applying pressure, and this air pressure is measured in terms of atmosphere, right? Atmosphere. Now this should be is atmosphere. The unit of measurement of atmospheric pressure is atmosphere. Now 1 atmospheric pressure is equal to the average air pressure at the mean sea level at 15 degrees Celsius, and we have already established this in terms of a barometric measurement. Atmospheric pressure of 1 atmosphere is equal to 760 millimeter of mercury rise. Now we know this, right? Basic idea. Now there are certain things about atmospheric pressure. Now in general, pressure also, atmospheric or pressure, how do you measure it? There are different units of measurement, right? There are different units of measurement. For example, there is a pound per square inch. There is kg per meter square, which is Pascal. There is bar also. I told you this. Atmospheric pressure is measured in millimeter of Hg, and pressure is measured in instrument called as barometer. And you also know there are certain characteristics of this atmospheric pressure. Atmospheric pressure, it continuously drops with increase in altitude. Why? It's very simple, right? Because this is Mother Earth. Now, Earth is exerting some sort of gravitational pull. And because of this gravitational pull, the air, that means air is made up of particles. These air particles are pushing down, are pushed down. But as I move higher in the altitude, the density of air itself goes on reducing. Along with it, the gravitational pull also goes on reducing. That is why what happens at high altitudes, atmospheric pressure and the available oxygen, it would be very, very low. That is why you must have seen, if you have traveled to high altitude places like Ladakh, you must have felt breathlessness. Why? Because our setup is made, our body structure is made in such a way that air should move from high pressure to low pressure. Air always moves from high pressure to low pressure. That means some sort of low pressure should be there in my lungs, because of which I can breathe. But if the atmospheric pressure itself is low, then it becomes difficult for me to breathe also. And that's why when you move in aircraft, you must have seen in aircrafts maintain cabin pressure. They maintain cabin pressure artificially so that it is comfortable for flying. So atmospheric pressure, as you go up, it decreases. Along with it, atmospheric pressure also defines your weather characteristics. Recently, a cyclone had come, right? A cyclone had come. Now, you must have seen in the cyclone, there is a low pressure area. So, if the atmospheric pressure is low, the air is going to enter that low pressure area. So, atmospheric pressure has a bearing, or it is a very good indicator of weather. Wherever there is a low pressure system, air is going to move inside. That means air always, we already established, air always moves from the high pressure zone to low pressure zone. So if there is a low pressure system, then air is going to move into it, causing cloudiness, probably precipitation also. But if there is a high pressure system, that means it is going to give you a very calm weather. It is going to be fair, calm weather, no signs of rain, right? So atmospheric pressure has these basic characteristics. All right. So what we established, we understood force, we understood different kinds of force, we also understood pressure, some day-to-day examples of it. So that's it right now in this particular video lecture. We'll continue our discussion in subsequent lectures. Now, before moving out, if you have liked this discussion, you can always follow me on this particular ID @Rahul Sai 222. You can message me directly on IG. I do respond on Saturdays and Sundays. Thank you for watching this again. Jai Hind.